Okay, so 6.4, when we're solving and factoring some polynomials here, let's look at example 3. With this, we can also, we got to see, can I rewrite this as a difference of cubes? Well, I don't have a cube here, I have a fourth, but what I can actually do is I can write this as a difference of squares, right? I can switch this 16 into a 4 squared, I can switch that 81 into a 9 squared, and I can switch that x to the fourth into x squared squared, right? Because squared times 2 times 2 is x to the fourth. So I can combine those two items together because they're both squared and make that a 9x squared, all of that squared, and a 4 squared at the end. Which means the difference of two squares, I take the first item minus the second, which is what I have right here. And I take the first item plus the second. Now because that's plus, that's basically done. There's nothing I can take out that's in common, so I'm basically done. However, if you look at this, I can actually keep going, right? I can rewrite the 4 as 2 squared, I can rewrite the 9 as 3 squared, so I actually have a difference of 2 squareds there because every item is squared. So I could rewrite that as 3 or x squared and 2 squared. So I have a 3x minus 2 and a 3x plus 2 because according to difference of squares you take each item with a minus sign and each item with a plus sign, and then all I need to do is bring down the x squared plus 4, and there is everything factored. With this example, for example 3, I continue on and I see what's in common. So before I can solve this, I need to take out everything that's in common. And they all actually have an x squared in them that I could take out, and they all actually have a 4. If I take a 4 out of each item, I have just a regular old 1 here. I have a negative 5 for the second term and a 6 for the last. If I take out an x squared, I have an x to the fourth first. I have an x squared left over, and there is no x's left over in the last one. So when we're doing this problem, I took that out. That's great. I know you're looking at that saying, well, great, you factored it, but what in the world else could I do? Well, see if you follow me through this. That's x to the fourth. I'm going to rewrite that as x squared squared. So now I have an x squared here. I have an x squared here. I even have an x squared here, right? So I have x squareds everywhere. What I'm going to do is I'm going to substitute that in, and maybe if I substitute a u in for x squared, this will show you a little better what we should be doing here to solve the problem. I plugged a u in everywhere where there is an x squared, right? The reason I did that is if you look here, that's now a quadratic equation. And in chapter 5 we talked that we could factor quadratic equations. So the point is, with this, if we are factoring the quadratic, can you think of two numbers that multiply to give you 6 that also add to give you negative 5? Well, I can. Negative 3 and negative 2, right? Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So the point is, when I go to solve something like this, I plug in the x squared back into the problem, and I get 4x squared, I get x squared minus 3 and x squared minus 2. And the reason why both of these are done is because I can't square that 2, right? There's nothing squared that'll give me 2, and there's nothing nice that's I can square and get 3, so I am officially done. So with example 4, before I can solve this equation, I need to put everything onto one side. So I'm going to subtract that 14x cubed. I'm just going to write it in standard form, keep it in order straight down. So I have 2x to the fifth minus 14x cubed plus 24x equals 0. I notice that they all have a 2 that I can factor out, and they also all have an x that I can factor out. So I take a 2x out, leaving me with an x to the fourth, a negative 7x squared, and a positive 12. Because I have this x to the fourth, I have an inkling that if I rewrote it as x squared like we did the last problem, x squared squared, I can put a u back into the problem everywhere where I see an x squared. So I put a u in there and there. So I want to try to factor that. Can you think of two numbers that multiply to give you 12 that also add to give you negative 7? I can. Negative 3 times negative 4 is positive 12. Negative 3 plus negative 4 is negative 7. So what that means is I have an x here and the u's. Well, what I can actually do is, why don't I separate these? And let's solve each of them. This means I would divide both sides by 2, so I would get x equals 0. I would add 3 to both sides to get u equals 3. And I would add 4 to both sides to get u equals 4. But here's the problem. The problem is, when you're doing this, I want to solve for x, not u. So we got to remember what I did from before. I made x squared equal u. So instead of that, let's go backwards and plug x squared in for u. So it's x squared equals 3 and x squared equals 4. So when I square root this, I end up getting x equals plus or minus root 3. And when I square root this, I end up getting x equals plus or minus 2. So if you think about it, that original problem was to the 5th power. Here's 1 answer, 2, 3 answers, 4, 5 answers. So in example 5, it says 1980, archaeologists at the ruins of Caesarea discovered a huge hydraulic concrete block with a volume of 330 cubic yards. The block's dimensions are x yards high by 13x minus 11 yards long by 13x minus 15 yards wide. So what is the height? Well, find a volume of something. It's length times width times height if we're talking about a block, right? Or a cube. So all I did was take each of these, length and width and height, and plug it in. And I know that it says the volume is 330, so I have 330 in there. All I need to do now is distribute. So I distribute. I got 13x squared minus 11x times 13x minus 15. Distribute there. So this is all I'm doing. I distribute. And while I'm distributing, I have to now combine my like terms. So I combine my x's squared, and there they are. And I also, since I'm solving for x cubed, I just combined everything onto one side. And because of this, there's 4 items. So because there's 4 items, it jumps out to me that I can factor by grouping. So in this item, I notice that there's an x squared that they have in common, and there's actually, I can divide each of these by 169. Over here, I realize that I can also take out a 165 from both of those items. And when I do that, notice how both these are the same, x minus 2 and x minus 2. So I combine those 2 in the front together and the 2 in the back, so I have 169x squared plus 165 and an x minus 2 at the back. So I can basically set each of these equations up to equal 0. I solve that by subtracting 165 on both sides. I divide by 169. And I get x squared equals negative 165 divided by 169. I square root both sides, but I realize that I can't have that answer because it's imaginary. So that can't work. So I go to the other equation. I add 2 to both sides to get x equals 2. So there's really only one answer to this problem, and that is 2. So that means I plug a 2 in to find out what the height would be. So the height of my block was just x. So the height is 2. So there's your homework. If you have any questions or concerns, please feel free to email me, and I will talk with you later. Thank you very much.